In this video, we study the concept of variables, constants, and assignments. So first, let's consider what actually is a variable. Well, you actually studied a close analogy earlier in the course. When you were learning about the components of the central processor, you were being taught about registers, small areas of superfast memory that have a specific purpose. Now, although you don't need to know about the different types of registers, one of them is called the memory address register. And at any one time, this contains the address of an instruction or data to be fetched or written to the memory. In a very similar way to this, a variable is nothing more than a pointer to a memory address which we're able to give a user-friendly label or name. So in order to go through these concepts, we're actually going to use a simple program written in Python, a beat that dice game. So this is a simple game for young children learning to compare 1 and 2-digit numbers. The rules are simple. A player rolls 2 dice. Doubles do not count and must be rolled again. The player's score is the value of the highest and the lowest dice combined, and the highest dice is always 4. So if a 5 and a 7 were rolled, the result would be 7-5, 75. So let's just do a quick example round. Craig rolls a 3 and a 4. The total of his throw is 43 because 4 is the highest of the two numbers. Note the dice are not added together, so it's not 4 plus 3 is 7, it's 43. Dave then rolls a 3 and a 3. The roll doesn't count as it's a double, so he throws again. He rolls 2 and 1. The highest dice goes first, so he gets 21. Okay, so here's the outline code written in Python for this game. And let's go through it now and pull out some of those concepts we mentioned at the start of the video. So here in this line, we see an example of a variable and we write total equals 0. And that's us assigning a value to our variable total. A variable is simply a value that can change or vary, hence its name, whilst the program is running. And it's simply an address in memory. Of course, referencing a memory address is very difficult for programmers, so having a user-friendly label like total is much more helpful, and it makes our code easier to read and understand. Now, every variable requires a data type, but in Python, unlike most languages, we don't actually have to declare our data type first. Python works it out based on the value you initially give it. So here we've said total equals 0, so it assigned the data type integer to the variable total. Here we see an example of a constant, rolls per player equals 2, and it looks exactly the same as our variable in Python. Now, a constant is a value which remains fixed and does not change while the program is running. So we must set it at design time when the program is first written. Now, the reason it looks identical here to the previous line of code we looked at is that Python doesn't actually support constants. If we wanted to implement constants in a Python program, we would have to set a value like we have here, rolls per player equals 2, and then we would have to make sure we never actually changed it. In most programming languages, you could actually declare this as a constant, and it would be unable to be changed during program execution. Assignment is simply when we give or supply a value to a variable or constant. So in both the previous lines of code we've looked at, we're supplying a value to a variable or a constant. An assignment is performed with the equal symbol. You assign the value on the right of the equal symbol to the variable or constant on the left. So here we see an example of an operator. Total equals total plus roll value. And operators can be used on variables and constants. So with this plus symbol, we are adding the contents of total to the contents of roll value, and then the result of that calculation is being stored back over the original contents of total. Now, the topic of arithmetic operators is covered in more detail in a later video, so we won't look at other examples now. You'll notice how we're actually using the plus operator here in two very different ways in our program. So in the first example, higher up the program, where we're saying roll value equals dice1 string plus dice2 string, we're actually joining together or concatenating two string variables. In the second example, the plus is performing an arithmetic operation of addition and is adding the value of total to the value of roll value. When the same symbol is used to do two completely different things, it's actually known as overloading, but this is not something you need to worry about at GCSE. Here we're carrying out two actions at once. The first is getting input from the user via the command input, and this is how we typically get input from, say, the keyboard, and we're assigning it to the variable user input. But at the same time, we're also casting or converting the value entered by the user from a string into a number, and that's performed by the command int. That's because even if the user presses the key 6 on the keyboard, that's the ASCII character 6. If we want it stored internally as a number, we have to cast it or convert it into an integer, and we do that with the int command. So there's two things happening at once in that line of code. We can see casting occurring in a number of additional places as well. So we can see in these top two lines that we take the value that's held in the variables dice1 and dice2, which are integers, and then we cast or convert those into their string equivalents, and then assign those to the variables dice1 string and dice2 string. You can see lower down, we take the contents of the variable roll value, and we cast and convert it to an integer before storing it back into roll value. We can actually cast from any data type to any other data type. The next thing to cover here is outputting, another quite common thing to do in programs. We gather input, we process that input in some way, but typically we also need to report the output to the user so they know what's going on. An output statement is used to print to the screen in Python. Here we've combined the contents of a string, dice1 colon or dice2 colon, with the contents of a variable, dice1 or dice2. You'll notice that strings are enclosed in single or double quotes, and this depends on the language. So this slide nicely summarises some of the core concepts we've been covering so far: variables, constants, assignments in casting. Pause the video and take some notes. You need to understand some of the advantages of using constants over variables, even if they aren't supported in the language that you've been learning, for example Python. So constants make a program easier to read, as they're usually declared and assigned at the top of the program. Constants can easily be changed by the programmer in one single place, that's where they're declared, instead of changing every instance of a particular value throughout a program, and this leads to less chance of errors. When you use constants, the compiler can optimize the code, and this makes a program run more quickly if constants are used instead of variables. So that's the theory content of the video covered. We're just going to spend a little bit of time talking about the programming language subset. If you've heard this before, you can skip the rest of this video. Otherwise, it's definitely worth a quick watch. So the exam board at EDEXCEL have released a document that they call the Programming Language Subset, which you can see here on the right. This document specifies which parts of Python 3 are required in order that the assessment can be undertaken with confidence. Students familiar with everything in this document will be able to access all parts of the Paper 2 on-screen assessment. The exam board will not go beyond the scope of this document when setting you any questions in the Paper 2 exam. Any students who do successfully use more complex methods, which are not included in the document, will still, however, be awarded marks. Further to this, you will see here from the front of the exam paper that you're actually going to be supplied with a printed and an electronic copy of the PLS during your Paper 2 exam. Well, if this document outlines everything you need to know in order to program in Python during the exam, and you can be guaranteed that you can answer all the questions using all the techniques in this document for full marks, then you might as well get used to using it now. Ask for a copy from your teacher and have it as a reference guide at all times throughout your GCSE course. It will be invaluable.